Welcome to this exciting video on C++ trees. Trees are an awesome data structure used to organize and store data in a hierarchical way, and they're used in so many cool applications like video games, scientific simulations, and operating systems. Today, we're going to explore what trees are, how they work, and why they're so important. By the end of this video, you'll be able to understand what trees are and how they're used in C++. Implement trees using different techniques, including binary trees and balanced trees like AVL trees and red-black trees. Perform common operations on trees, such as searching, inserting, and deleting nodes. Apply trees to real-world problems and algorithms, such as sorting, searching, and indexing data. So, what exactly are trees? Well, simply put, they're a way of representing data as a tree-like structure in C++. In a tree, each node can have multiple child nodes, and there's only one root node at the top. Think of it like a family tree or a branching diagram. Now, how do trees work? Well, each node in a C++ tree represents a piece of data, and the connections between nodes represent the relationships between the data. For example, in a file system tree, the root node represents the root directory, and its children represent the directories and files within it. Trees can have multiple levels, with the root node being at level 0, its children at level 1, their children at level 2, and so on. The height of a tree is the number of levels it has, and it determines the maximum number of nodes that can be in the tree. Trees can be implemented in different ways, but all types of trees have one thing in common: they allow us to search, insert, and delete data efficiently. They're optimized for these operations, which means that they're lightning fast even with large amounts of data. Okay, so we know what trees are and how they work, but why are they so important? Well, for one thing, they're used in a ton of different applications, from database systems to operating systems. They're also really efficient, which is crucial when working with large datasets. But what makes trees truly exciting is the way they allow us to solve complex problems. With trees, we can implement algorithms for sorting, searching, and indexing data. We can represent complex relationships between data, like a social network or a decision tree. And we can do it all in a way that's fast and easy to use. In conclusion, trees are an amazing tool that allow us to organize and manipulate data in so many ways. They're fast, efficient, and incredibly versatile, and they're used in all kinds of cool applications. In the next section, we'll dive deeper into how trees are implemented, including different techniques for balancing and optimizing them. So what are you waiting for? Let's get started.